Imagine the literal end of reality. Yeah, cue that strange, echoing, atmospheric sci-fi music in your head, because today we are taking a seriously mind-bending journey in this explainer. We're going all the way from the dusty debates of ancient Greece straight to the absolute end of the cosmos.
Let's just jump right into the ultimate existential question, shall we? Will everything you know actually end? Like your family, our planet, our sun, the entire universe. Is it all just going to fade into absolutely nothing? I know, it's a super heavy thought, but it's exactly what basic physics predicts. Everything has an expiration date. But how do we actually know that for sure?
Well, at the heart of this whole thing is a debate that goes back literally 2,000 years. On one side, you've got Plato. He believed our imperfect earthly world was created, meaning it had a sudden, specific beginning. But on the other side, Aristotle argued that nature abhors a vacuum. He was convinced the universe was eternal, just constant matter, no beginning, no end. And honestly, for centuries, this philosophical gridlock completely ruled human thought. But then, that ancient gridlock finally totally broke in 1923. That year was a massive, game-changing turning point in human history. It all happened when a young American astronomer named Edwin Hubble was peering through the massive Hooker telescope. At the time, this was the largest telescope in the entire world, perched way up on Mount Wilson in California.
And what Hubble found, it completely shattered our understanding of existence. He spotted a pulsing Cepheid variable star inside a spiral cloud. Now, when he ran the calculations based on its pulses, the math revealed it was a staggering 2.5 million light-years away, which is insane. This proved, for the very first time in history, that this cloud wasn't just some local gas in our neighborhood. It was an entirely different galaxy, Andromeda. Other galaxies beyond our Milky Way actually existed.
So Hubble kept digging, and he applied the Doppler effect to these newly discovered galaxies. He realized that the light coming from them was shifting into red frequencies. Now, you know how a siren drops in pitch as an ambulance speeds past you? It's the exact same concept. Light stretches into red frequencies when it's moving away from you. So this meant these galaxies were literally racing away from us. And the wild part? The further out they were, the faster they were moving.
This massive discovery led a Belgian physicist and clergyman, Georges Lemaitre, to picture the universe kind of like dots drawn on a balloon that's being inflated. He predicted that if everything is expanding outward, constantly stretching space over time, well, then we must be able to just rewind the clock, right? If you go back far enough, the universe must have been born from a single, tiny, infinitely dense point. That moment of birth is what we now famously call the Big Bang. So, turns out, Plato was right. The universe did have a beginning.
But here's the catch. A beginning almost always implies an end. And that brings us to the second law of thermodynamics, and this absolutely crucial concept called entropy. Basically, entropy is the irreversible measure of disorder and chaos. It's the exact reason why if you drop your favorite coffee mug and it shatters on the floor, it's never going to just spontaneously reassemble itself. It proves time only flows in one direction, driving absolutely everything in an isolated system from perfect order straight towards absolute chaos.
Which naturally brings us to a pretty terrifying question. So, how does it all end? If our universe is an isolated system, totally governed by entropy, constantly expanding and losing its order, what exactly is our final destiny? Let's dive into the leading theories.
Right now, we're basically looking at two major cosmic doomsday scenarios. For a long time, some scientists actually thought gravity would eventually hit the brakes on all this expansion, reverse it, and crush us all back down into a tiny singularity. They called it the Big Crunch. But then, in 1998, astronomers were totally shocked to discover dark energy. And not only is it there, it's actually accelerating our expansion. If this mysterious dark energy grows way too powerful, it could eventually rip the very fabric of space apart in a catastrophic big rapture.
Okay. But before we get ahead of ourselves and talk about the absolute end of the entire universe, let's zoom in locally for a second. What's the fate of our sun? Like, what is actually going to happen to our very own 4.6 billion-year-old star, the literal source of all life on Earth? Let's walk through how this local apocalypse builds, step by step. See, every billion years, our sun burns its core hydrogen about 10% hotter. So step 1, helium starts building up in the core. Step 2, this intense heat triggers a catastrophic greenhouse effect right here on Earth. Our oceans will literally boil and completely evaporate. And then step 3, the sun's radiation splits those water molecules apart, and our atmosphere just escapes completely into space. Earth basically becomes a barren, dead desert, totally pushed out of the habitable zone.
But believe it or not, the disaster hasn't even peaked yet. because in about 5 billion years, the sun is going to completely run out of core hydrogen. To survive, it's going to start burning its outer layers, expanding into a monstrous red giant, roughly 20 times its normal size. It will completely swallow the inner planets. Yep, including Earth. Gone. And eventually, after shedding its outer layers in these massive explosions, our once mighty sun will just wither down into a dead, glowing white dwarf stone. Basically, a cosmic gravestone.
As if losing our entire solar system isn't enough to process today, we also need to ask, what about the Milky Way? Like, what massive object is hurtling toward our entire galaxy right this very second, even as you're sitting here listening to this explainer?
I want you to consider the number 110. That's 110 kilometers per second. It is a dizzying speed, and it's exactly how fast our neighboring Andromeda galaxy is rocketing straight toward us. That's right, we are on a direct collision course, setting us up for a massive galactic crash in about 4 to 5 billion years.
Now, before you panic about stellar crashes, hold on. Let's put this into perspective. If the sun were the size of a ping pong ball and the nearest star was a pea, they would be 1,100 kilometers apart. Space is just so unbelievably, incomprehensibly vast that actual stars colliding during this galactic merger is almost impossible. Instead of some fiery cinematic crash, our solar system would likely just quietly drift into the outer shell of this newly merged supergalaxy.
Okay, now we must ask the most chilling question of all, bringing it back to the fate of the entire cosmos. What is the ultimate heat death? Let's look back at Lord Kelvin's 19th century prediction. He figured that the universe, being a closed system, will eventually reach maximum entropy. It'll just run completely out of usable energy and enter a permanent state of absolute, unchangeable cold.
Let's track how this dark timeline actually plays out. In about 100 million years, those supercommon red dwarf stars, they're going to exhaust their fuel and die off, becoming these ultra-dense black dwarfs. Fast forward to 100 billion years, and so many stars will have died that our night sky is going to go completely pitch black. And then, by 1 quintillion years, which is a crazy number to even say, theoretical physicist Freeman Dyson calculated that surviving dead planets will just lose their orbits and drift randomly through an endless freezing void.
But somehow it actually gets worse, and it's all due to a concept known as proton decay. According to the physics of the far, far future, eventually the actual subatomic building blocks of matter itself, the protons inside literally every atom, are going to break apart. That means the remnants of those planets, dead stars, and atomic dust will literally just dissolve. Everything left in the entire cosmos will fade into sheer nothingness. These next numbers are honestly almost impossible to comprehend. After all that matter decays, the only things left will be black holes. But guess what? Even they aren't eternal. Through a slow process called Hawking radiation, black holes actually leak energy. In 10 to the 67th years, small black holes will completely die out. And it will take 10 to the 106th years, which is a million Google years, if you can even wrap your head around that, for the giant, galaxy-eating supermassive black holes to shrink, evaporate, and just disappear completely.
And that right there brings us to the ultimate end of our story. Absolute zero. Once that very last black hole evaporates, there's no more light, no motion, no vibration. It'll just be a sparse, incredibly thin soup of random electrons and photons drifting around in an infinitely dark, cold, and completely dead cosmos. The universe officially reaches maximum entropy. It is totally, finally over.
So as we wrap up and realize that our universe is just as mortal as we are, born in a brilliant flash and dying in the absolute cold, I have to leave you with this final, kind of haunting thought. We are made of the very elements of this cosmos, right? We act as its living witnesses. But in 10 to the power of 106 years, when it all goes completely dark and the very last drop of energy fades away, who will be left in the void to know that we were ever here at all?